Hi all, welcome back. This session we will see the TCP IP reference model. So before moving into different layers and its function, let us have a walk through the history of this TCP IP reference model, by which you can have an idea about what were the major design goals of designing this TCP IP reference model. Actually, this TCP IP reference model was the model used in the first wide area network, that is ARPANET. ARPANET stands for Advanced Research Project Agency Network, which was the network used in the Department of Defense in US. And later this was successfully implemented in our internet, which is the most widely and commonly used network today, right? And this ARPANET, which was a research network sponsored by Department of Defense in US, it was mainly comprised of hundreds of universities and government installations. And initially all these were connected using leased telephone lines. Later, radio and satellite networks were also added. So when these new networks are added to the existing network, the existing protocol had some trouble in internetworking with them. So a new reference architecture was needed. So first we can say that the first design goal of this TCP IP reference model was the ability to connect multiple networks in a seamless way. And this led to the development of TCP IP reference model. And another worry or another issue in ARPANET, especially because it is a network used in defense, is that at any moment its precious host, routers or even gateways might get blown into pieces, right? So another major design goal was that network be able to survive any type of losses in subnet hardware, with the existing conversation not being broken off. Or we can say that the Defense Department wanted the connection to remain intact as long as the source and destination machines were functioning. Even if some of the machines in between or the transmission lines in between were suddenly put out of operation, the connection should be remain intact. Okay, that was the requirement. Furthermore, the third requirement is that a flexible architecture was needed. Just because divergent requirements were expected, right? Different applications with divergent requirements were expected. So say just for example, starting from a file transfer to even a video conferencing, audio video communications. So lot of divergent applications are expected to run on this reference model. So a flexible architecture also was expected. So these were the major design goals of developing this TCP IP reference model. So now let us just turn into the different layers and its functions. We compare this TCP IP reference model with our OIC reference model. This is how it looked like. So application layer is present in both reference models, whereas the presentation and session layers are not present in TCP IP reference model. So the main functionality of these two layers are done by the application layer itself. Transport layer is present in both of these models. The network layer is present, is just renamed as internet layer in case of TCP IP. And the data link and physical layer is combined together here to form the host to network layer. Now let us get into different layers and its functions. Okay. So of course we have a set of design goals in our hand, right? We have a set of requirements. So definitely the network layer is the layer which should support all these requirements. So let us start from there, and in this case it is renamed as internet layer. Keeping all these requirements in this design, the design led to a packet switch network. So whatever happens in between, as long as the end system, the sender and receivers are there, they are live, the communication should proceed in some way, right? So whatever happens to the intermediate network, as long as some paths are available, the communication should proceed. So based on that requirement, a packet switching network is designed. Okay, and based on the connectionless internet network layer. That means whatever paths are available, the data should be proceeded or data should be transmitted. So the job of this network is to permit host to inject packet into any network and let them travel independently to the destination. Probably the different packets may definitely follow different paths, right? And they may arrive at the destination in a different order than they sent. So in which case it is the job of the higher layers to rearrange them to make them in an in-order delivery. Okay. So the major functions of this network layers are packet routing and then congestion control. Okay. And in TCP IP, the network layer having some protocol to support these type of functionality. The main protocol is IP, that Internet Networking Protocol, or in short Internet Protocol. And 4 different supporting protocols are the ARP, RARP, ICMP and IGMP. So this is the protocol stack for TCP IP reference model. Protocol stack means the set of protocols arranged in different layers. So corresponding to each layer we have a set of functions, right? And to implement these functions, a set of protocols will be there. So we are talking about the network layer. So we have 5 different protocols to support the functionalities of internet network layer or internet layer. Okay. So IP is the main protocol, and we have ICMP, IGMP, ARP and RARP to support this IP. So we can see one by one. First one is the main protocol, that is Internet Protocol or Internet Networking Protocol. This is the main protocol or the most important protocol of the TCP IP network stack. It implements internet networking. To corresponding to networking, routing and everything, all the functionalities are done by this IP protocol. IP is actually an unreliable connectionless protocol. Still, it provides the best effort delivery. So unreliable means it provides no error control. Okay. And it's connectionless. Different packets of the same message may follow different routes to reach the destination. Still, it provides burst effort delivery. That means it assumes that the underlying network is completely of different types of errors, like the links can be failed, nodes can be failed, lot of other types of errors can be there. Still, it assumes or it tries its best to provide the accurate delivery, that by rerouting packets through some alternative routes, or by avoiding or detecting and solving congestion, like that. Lot of other things are done to provide a burst effort delivery. And it is a host to host protocol. It tries to or it transmits the packet from the sender host to destination host. So we can see here that we have a client machine and we have a server machine. Suppose the client, we are just doing some browsing. Okay, we are searching something from the internet. So from our browser, the request should be reached into the server, right? The web server program in some server. Lot of alternative machines will be there in the sub network or the internet network, which is connecting this client machine and server machine. So using this protocol, TCP IP reference model and the corresponding IP protocol in the network layer, we have different possible paths to the destination and different packets from the same application or same invocation or same browsing may follow different paths to reach the destination. Say first packet may follow this path and the second may follow this path, like that. Independently, each packet will be routed to the destination server. That is the IP routing. And now next, coming to the supporting protocol, first we have the ARP. ARP stands for Address Resolution Protocol. It is used to find the physical address of a node after its network address is known. So let us take the web browsing example here also. So if you want to search for something, you will just type the corresponding URL, right? Just for example, google.com you will type, and how this request is forwarded to the Google server. Yeah, definitely some mapping should be done to get the IP address of the server, right? Then only we can route the data or route the request. Yeah, for that we have the DNS server, domain name system servers are there, and DNS server will map this URL into corresponding IP address. So using this DNS server, we will get the IP address of the destination server machine, right? But if you want to send some data, this IP address is not enough. As you know, in the data link layer, this data will be embedded or attached with the corresponding MAC address of the destination also, right? Then only we can forward the data through the media. So how to get the MAC address of the destination? For that, we will use the ARP protocol. So we know the IP address, we need the MAC address. For that, we can use the ARP protocol. So let us assume that host A is the sender machine and this host is the receiver machine. and host A knows the IP address of the receiver machine, but it does not know the MAC address. So it will just forward a ARP request packet. This ARP request will contain the IP address and MAC address of the sender machine and the IP address of the receiver machine. It requests for the MAC address of the receiver, and it will just forward this to every machine. It will broadcast the corresponding request. Okay, and upon receiving this request, the machine with the corresponding IP address will respond. Okay, so here in this case, all the three will receive the corresponding request, but this machine only will respond because that machine contains the requested IP address. It will respond with its own MAC address. Okay, and this reply will be unicasted to the intended recipient because this ARP request contains the address, IP address and MAC address of the sender, right? Using that, the reply will be unicasted to the corresponding sender. So this is how ARP works. The next protocol is Reverse Address Resolution Protocol, or RARP. It's actually the reverse of Address Resolution Protocol. That is, it is used to find the internet address of the node after its physical address is known. That means if a machine knows its MAC address but it doesn't know the IP address, in that case you can use the RARP protocol. Just for example, when a machine is newly connected to the network, in that case it doesn't know the corresponding IP address. Its MAC address will be imprinted in the NIC, right? It can easily get it, but it doesn't know the IP address. In that case, it can request for the corresponding IP address, and each and every local network will contain a machine which is configured as the RARP server. RARP server will contain information regarding each and every machine connected to the corresponding network. The information like the MAC address of the machine and the corresponding IP address. So when a machine requests for its IP address, this RARP server will respond with the corresponding IP address. So this machine is newly connected to the network and it wants to know its IP address. So it will just broadcast a request, RARP request, because it does not know the address of the RARP server. It will just broadcast the request. What is the request actually? My physical address is this and I am looking for my IP address. Okay, and this request will be received by all the machines in the network, and upon receiving this request by the RARP server, it will respond. Okay, so you can see the reply from the RARP server here. Your IP address is this. Okay, only this machine will respond, and this reply will be unicasted to the corresponding host. This is how the RARP works. So if we compare this ARP and RARP, in case of ARP, given the logical address, it will provide the physical address. Right? In RARP, given the physical address, it will provide the logical address. Two more protocols are there. One is ICMP and another one is IGMP. So ICMP, that is Internet Control Message Protocol. As you know, the IP does not provide any error control, right? To support some type of error control mechanism, this ICMP is used actually. So it is used by hosts and gateways to send notification of datagrams, problems, okay, back to the sender. You can see an example for that. Suppose this machine A wants to send some message to host B through some intermediate routers and gateways. Say suppose we have one router R1 here, and suppose the link from R1 to host B is actually failed. There is no way to reach host B. In that case, the ICMP message or ICMP protocol inside this router will intimate the corresponding sender that this host B is unreachable. Such error control mechanisms are provided by this ICMP protocol. And coming to the next protocol, that is Internet Group Message Protocol, or IGMP. It is mainly used for group management, for example, multicasting. You know what is multicasting, right? We have different types of information communication. One is unicast, multicast and broadcast. If a particular message is sent to only a single receiver, that is called unicast. And if a message is sent to multiple machines simultaneously, so a subset of the entire machines in a network. And this message is sent simultaneously. That is called multicast. And if the corresponding message is sent to every machines in the network, that is called broadcast. So 3 types of communications are there. So in the case of multicast, we have to maintain some information like which and all machines are belonging to a particular group, right? And how these machines are joining, leaving in a group like that. So when a router or gateway receive a message, it should decide, just for example, in the case of multicast message, to whom and all this message should be forwarded, who and all belonging to a particular group, like that. All these informations are managed using this IGMP protocol. So these are the supplementary protocols in IP layer. Now we are moving to next layer, that is physical and data link layer. So no specific protocol is defined at this layer, rather TCP IP model support all the standard and proprietary protocols. Just for example, if the underlying network is a WAN, the corresponding protocols will be supported, or if it is a LAN, in that case corresponding Ethernet protocol will be accepted or supported by this TCP IP reference model. The next layer is transport layer. As you know, the transport layer is responsible for process to process delivery of a message. Network layer is responsible for host to host delivery, whereas transport layer is responsible for process to process delivery. And here in case of TCP IP, there are 2 different protocols to support this transport layer. Those are TCP and UDP. Okay, and all the functionalities in case of IC reference models are also here, like service point addressing. The port address will be attached with every data segment, and segmentation and reassembly will be done. And then these are the 2 different supporting protocols. First one is user datagram protocol, that is UDP. It just provide a connectionless or unreliable services. Okay, that is this datagram will be forwarded. In that case, in case of UDP, the data units are called datagrams, and these datagrams will be forwarded through whatever paths are available between the sender and receiver. Okay, so it provides a fast delivery, but there is no error control, or the corresponding communication will be unreliable. And in case of transmission control protocol, it's connection oriented and reliable. So before communication, a dedicated path will be established between the sender and receiver, and all communication will be done through that established path alone. So all the information will be transmitted in correct order, and without any duplicates or error, it will be received correctly at the destination. So it will be reliable and connection oriented in the case of TCP. So as you know, in the case of IC reference model, in case of TCP, a connection will be established first using some handshaking protocols and all. And so only after establishing a connection, the actual data transfer will be done. And this connection will be there as long as the last data unit to be transmitted. After that, this connection will be released. Whereas in case of UDP, the messages will be transmitted between the sender and receiver through any available path between these 2 machines. So in that case, message may be lost in between, right? Duplicate may be arrived. Those are not addressed in case of UDP. Anyway, the communication will be fast. So in case of some video streaming and all, we can use this, where delay is not at all tolerable. Rather than the quality can be compromised a bit. Whereas in case of TCP, so first connection will be established, and for every message an acknowledgement will be received. So every message will be exactly received once, and no duplicates will be received, and no message will be lost. So, and every segment will be received in the correct order in the destination. That is TCP. And the next layer is application layer, which is a top layer. And in case of TCP IP, this layer performs the functions corresponding to all the 3 layers in IC reference model. Those were application, presentation, and session layer. So this layer contains different protocols corresponding to each different types of applications used by the user. Just for example, it contains a protocol for file transfer, that is FTP. Then web-based application is have the HTTP protocol. Then domain name systems are the file system NFS, network file system protocols are the. So corresponding to each and every user applications, a protocol will be there in the application layer. So this is all about this TCP IP reference model. Thank you.